All right. So, guys, what we're going to do is we're going to practice finding the average rate of change over certain periods of time. And this is kind of a challenging activity, but I really want you to see if you can follow with me. This first one is from 10 a.m. to 12 p.m. So that's from right here is 10 a.m. So starting right there, ending right here. We're trying to find that average rate of change. So it's exactly what we just practiced with Usain Bolt. We're going to figure out our change in time, how long it's been. So from 10 o'clock to 12 o'clock, that's a total of 2 hours. Okay. Then we have to figure out our total change in distance. So we're right here. That's about 125 all the way to right here, which is 200. So we went from 125 to 200. That's a total change of 75 miles. Okay? So to find our rate of change, once again, to find our slope, we take our distance divided by our time. So that's 75 divided by 2, which gives you approximately 37.5 miles per hour. So that was our rate of change from between 10 a.m. to 12 p.m. 37.5 miles per hour. What about from 12 to 12:30? This little guy right here. What do y'all think about that? What's my rate of change there? Tell a neighbor, what do you think? What do you think's happening? You may notice that the line is flat, right? Our little line here is flat. So what does that mean? If the line is flat, that means that there's no change in distance. Time is passing, but there's no change in distance. So if there's no change, what that actually means is that we are driving 0 miles per hour, aka we are stopped. We haven't moved anywhere. We're stopped. That's what that means. Okay? So 0 miles per hour. Where do you think that we're going the fastest? Where do you think that we're going the fastest? When you look for the fastest rate of change, hopefully you're looking for where the line or the graph is steepest. So this is where I think we're going the fastest. You can compare that to maybe this one down here, but the top one is definitely in green is where we are going the fastest. So right down under there that you're looking for the steepest section. Okay, you're looking for the steepest part of the graph. And so that one is from 12:30 all the way to 2 p.m. Okay, that's what we're looking for is where we are the steepest. And then last but not least, the average rate of change from the very beginning to the very end, once again, is distance divided by time. So if it's distance divided by time, let's cross that out. What's my total distance and what's my total time? Well, if we come back to our graph here, my total distance from the very beginning, distance 0 to the very end over here is 300 miles. That's a total of 300. You can see that right there, 300 miles. So my total distance is 300. Let's put that on the top. And now, how long has it taken me to drive that total amount of 300 miles? Well, from time 8 o'clock in the morning to 2 o'clock in the afternoon, that's a total of 6 hours. So hopefully you've got a 6 for 6 hours down there. So 300 miles divided by 6 hours. If we simplify, that leaves me with 50 miles per hour. That's our rate of change. So anytime we look for our rate of change overall, we always go from the beginning to the end. All right. So some notes now. This is really important that we understand these notes, and I just have to reveal these here for you. So really want to be very careful. The slope is the rate of change. All right. When the rate of change is constant. That's so important. You only find the slope when your rate of change is constant. Constant means that it's not going slower and then faster and slower, and then it's a constant rate of change. If it's 10 miles per hour, then it's always 10 miles per hour. If it's 50 miles per hour, then it's always 50 miles per hour. Well, how do we calculate that? Before we can calculate it, we're going to talk about the fact that it's the rise divided by the run. The rise divided by the run. What I mean by that is Rise is going up and down on the graph, up and down on the graph. So if it's up and down on the graph, what we mean is that's the vertical change. Going up and down is your vertical change. Did you go down 3? Did you go up 4? Did you go up 7? Did you go down 2? What's your vertical change? Now, the run is a left or right talk. Run is left and right. That's called our horizontal change. Did you go to the right 3? Did you go to the right 4? Did you go to the right 9? Most of the time, we're always going to go to the right, and very, very, very rarely are we going to go to the left. That's the horizontal change. So right here, look at these two graphs. We're going to actually look at their horizontal and vertical change, and that'll help us determine the slope. So we start with the vertical change. Always do the vertical change first. And you always have to start on the left-hand side of the graph. We always read a graph from left to right. So we've got a point there, and we've got a point here. So to get from this first green point to the second green point, we have to rise. And notice how many I rose. I rose 2. That's my vertical change. Write that number right next to it. And now I'm about to run. 1, 2, 3, 4, 5. Run 5. So we've now identified the rise is positive 2 and the run is positive 5. So our slope is 2/5, 2 over 5. Okay, same idea goes for right here, except this time from this point to this point, we're actually rising in the negative direction. We went down. So because it went down, it's a negative 2. You cannot forget that negative. It's a negative 2. Now we run 1, 2, 3, 4, 5, 6. So that's a positive 6. So our slope here is negative 2 over positive 6. Hopefully you're looking at that fraction and be like, hold up a second, negative 2 over positive 6. We can simplify that so you actually can. It simplifies down to negative 1/3. Okay? So hopefully you're seeing our rise and our run is all about finding the vertical change first, the horizontal change second, and that allows you from the graph to find the slope of our line. Okay? So that's finding slope from a graph. Let's keep going here. We can actually now start using slope from 2 points, but in order to find the slope from 2 points, we have to have the formula. So this is absolutely one of the most important formulas you'll learn all semester. You'd start by finding the difference in the y coordinates. So this is my second y right here. My second y is this point right here. And we subtract that from the first y, that one right there. Y2 minus y1. So y2 stands for the second y, and then we subtract that from the first y. Y2 minus y1. Now, we then divide that by the x's. X2 minus x1. So x2 minus x1. Subtract that x1 from the x2 minus x1. This formula is so important to be able to find the slope between 2 points. So I'm going to model it for you and then let you try the second one on your own. So first thing I'm going to do is I'm going to label my points. We've got to label my points. Don't be lazy. Label our points so that we know which one we're talking about. If we don't label them, we're probably going to screw up which one goes where. Then we have m equals, we're trying to find that slope, m equals y2 minus y1. Y2, this is our y2 right here, minus y1. Be careful how you set that up. So y2 is negative 2 minus y1 is just 0. Okay, now we're going to go to the bottom and subtract x2 minus x1. All right, so positive 3 minus negative 1. Now here's where we got to be very, very careful. You got to be careful right here. 2 negatives create a positive. All right, 2 negatives create a positive. So you've got to be careful how you bring that together. We're left with negative 2 over 4, which simplifies down to negative 1/2. Try the next one with your neighbor. Keep it up. Best of luck.